Hello students, this is lesson 3 and 4, water, glacial, and wave erosion. So we're going to start with how water causes erosion. So water erosion can be in two ways. It does not always have to be fast. It can be giant waterfalls, which is really fast, or it can be tiny, slow splashes of little raindrops. This can happen both on the surface of the earth and underground. And our only new word right now is runoff. So runoff is erosion on the surface of land, and this is water picks up sediment and carries it on the surface. And just to review, erosion is when bits of rock are weathered away. Sediment are the bits of rock that are broken down. And deposition is when sediment builds up somewhere new. And we had those words last time. So, new things, factors that affect runoff and water erosion. So the first thing that affects this is the amount of rain. So a place that gets heavy or long-term rain adds water more quickly to the surface than somewhere that gets a little bit of rain. So somewhere like around here would get more rain than a desert, so we would have more runoff and more water erosion than a desert area. Vegetation or plants, grasses, shrubs, trees, other plants have roots that reduce runoff by absorbing the water and holding the soil in place. So plants actually reduce runoff, and so if you cut down trees and you cut down plants, you're actually preventing or you're actually increasing the amount of erosion you're going to have. So the type of soil affects the amount of and type of runoff you're going to have. So soil that is full of sand and clay is going to absorb and hold more water than soils that are going to have or be primarily made of gravel and silt. So these kind of soils, excuse me, are going to affect your type of runoff and erosion. The shape of the land, hilly, slopey areas and mountainous areas are going to have more erosion and runoff than flat ground, and how the land is used. So areas that have people and pavement and roads and sidewalks, those kind of things do not absorb water, where soil and plants and things like that are going to absorb more water. All right, river formation. So gravity is going to cause this water to flow downhill. And the first things that happen are little tiny grooves are formed in the soil or in the ground called rills. And then those rills join up to form what are called gullies. So rills and gullies form first. And these things fill with water during a rainstorm or a flood, but they're supposed to dry up. So they, over time, fill and dry. But eventually, these rills and gullies form streams. Streams don't dry up, or they're not supposed to dry up. Streams are also called creeks and brooks, and they continue flowing. Streams will join together then to form rivers. So rivers are big. Rivers are bigger than streams. Streams are smaller. Streams join together to form rivers, and when many streams flow together, they form rivers. Tributaries are just one river that flows into another river. Pretty much any river can be a tributary. It's just one river or stream that flows into a larger one. So here in Pittsburgh, we have the Monongahela and the Allegheny rivers. These are both tributaries to the Ohio River. But the Ohio River is a tributary itself. It is a tributary to the Mississippi River. Okay, so does not mean that just because you have tributaries yourself does not mean that you also cannot be a tributary. So pictures of what these look like. Rills are small, gullies are bigger, and gullies can dry up, rills can dry up, but these things from the pictures will fill with water when it floods and rains. They're supposed to, and that water will then run off, is our word, that water will run off into then a stream. So the picture on the right is a stream. Streams are filled with runoff water from gullies and rills. And you can see in the picture on the left, you have the river, and you can see the smaller tributary flowing into it. So watersheds are the areas from which rivers and tributaries get their water. These are also called drainage basins. And I really like this picture because it's showing the Mississippi River watershed, which is basically every river in the United States that connects into the Mississippi River. So it's a huge, vast area of the U.S. that connects in some way to the Mississippi. So it's a huge area in the central U.S. and then anywhere that's not connected has its own watershed or its own area where they get their fresh water. All right, other river features. You have waterfalls. Waterfalls form because soft rocks erode faster than hard rocks. So the waterfall creates a cliff and the water falls off the cliff. Floodplains. Okay, floodplains are wide, flat areas of land along a river. And floodplains are supposed to flood. That's their whole purpose. Okay? Floodplains are supposed to control flooding, and they have soil rich in nutrients. So if you look at the picture down below, in a floodplain, if you were to build your house along the river or along the riverbanks in the left-hand picture, you could see when it rains, your house would flood. So the idea of a floodplain is you stay away from where the river is because it's that area is supposed to flood. That's the point. So you stay away from the riverbank for building and construction. That land is good soil. That's fertile soil. It's rich in nutrients, but for building and construction and things, you want to keep away. Some construction companies still try to divert the river and straighten out the river and still build it near the river, and then they get mad whenever, oh, this land floods. Well, duh, it's a floodplain. All right, other words. So a meander is just a curve in a river. Okay, so you can see in the pictures where meanders curve, and sometimes meanders will curve so much that those curves connect and they form what's called an oxbow lake. Okay, so the oxbow lake is the picture on the right, where the oxbow lake actually gets cut off from the rest of the river. So the river parts join up and the lake gets cut off from the rest of the river. The oxbow lakes tend to be devoid of nutrients. There's no new water flowing to them, so they can dry up, or they can be like this one in the picture, full of algae and overgrowth, with no new water supply coming into them. They're not really great areas for swimming or for fish and wildlife. All right, so another picture of what an oxbow lake looks like. You can see this one is starting to dry up. It's not as long as it used to be. Other river features. So these are land features formed by rivers. Deltas and alluvial fans are land features. Okay? So a delta is where a river flows into an ocean or a lake and is a land feature as sediment builds up. An alluvial fan looks like a fan, and this is when a stream flows out of a mountain valley and forms that characteristic fan shape. All right, you will need to open up this PowerPoint, or this video is linked in your assignment, to read and listen about estuaries. So groundwater and geology now. So off of rivers and onto something else. So groundwater is water that seeps underground. How about that? And this is still on geology. So if you didn't realize, geology is the study of earth. Geo, the prefix, means earth. Anything that ends in ology is the study of. Okay? So in groundwater erosion, this is a chemical weathering. And we're dissolving limestone rocks to create caves, caverns, or sinkholes. And in groundwater deposition, where that sediment builds up, this is water droplets that are containing minerals, and those little tiny drops over long, long periods of time, thousands or millions of years, are creating cave formations. So you get stalactites, and these hang like icicles from the roofs of caves, or stalagmites that those build up on the floor of a cave. So mites are from the bottom, tights are from the top. And sometimes they completely connect and you get what's called a column. So an idea of what these look like in a real cave, picture on the left, you get the tights from the top and the mites from the bottom, and you can see a couple columns have formed in this cave. And then the cartoon picture on the right where they're actually labeled stalactites, stalagmites, and columns. Okay, karst topography. This is areas on Earth where limestone rock is underground, but close enough to the surface where these areas are accessible to groundwater, and because that limestone dissolves, these are areas prone to sinkholes. These are also areas prone to caves, but those caves are also prone to sinkholes and collapse. So anywhere in green on the left side are areas that are karst, or areas prone to sinkholes and caves in the United States, and on the right are areas prone to sinkholes or caves in the whole world. So, and it just so happens to be, it's just luck of the draw where the limestone happens to be on Earth. So glaciers. Glaciers are large masses of ice that move slowly over land. It's like a large frozen moving river. And some facts about glaciers. Glaciers only occur where it's cold, and anywhere where they are moving towards it's warm. they will begin to melt. So all water on Earth is part of the hydrosphere, but if it's frozen, it's part of what's called the cryosphere. Glaciers cover 10% of Earth's land and almost all of Antarctica and most of Greenland. If they reach the ocean, they break off and they're called icebergs. Most of Earth's mountain ranges contain glaciers at their highest peaks and valleys. Glaciers are always moving. Even if they're really moving slow, they are still always in motion. And unfortunately, due to climate change, many of Earth's glaciers are melting at an alarming rate. So they're melting faster than we expect. Okay, so some pictures of what glaciers look like. Some have reached the ocean, some are creeping down mountains, some are already at the ocean, but they're just big chunks of ice. And our last part, okay, ocean waves. Just like rivers, just like frozen glaciers, ocean waves are also causing erosion. Okay, same idea. Weathering, erosion, deposition, same things happening, but just in the ocean. But where river water can be causing this anywhere on Earth, anywhere, and karst can happen anywhere where there's limestone, ocean waves are only happening at the coastline, so anywhere where the ocean meets the land. So the ocean waves weather away the rocks near or the sand near the coastlines. Erosion then pulls that rock and sediment away from the coast and changes what the coastline looks like. But then that sand and rock has to go somewhere, so it gets deposited somewhere else. So this creates sandbars, new islands, changes the shape of the beach. So ocean waves are constantly changing what our coastlines look like. All right, you have an assignment on Schoology. Go ahead and work on that, and let me know if you have any questions.